Okay, so now we're going to talk about what is called the common logarithm. So, a logarithm with base 10 is called a common logarithm and is just so common that we write it without the base. So, what I mean by that is log base 10 of x, we just write as log of x. No number required. Kind of like how, the square root of a number has an index of 2, but we don't write the 2 because square root is so common. So, just like that idea, logarithms of base 10 are just so common that we don't even write the 10. So, using this, all right, well, I mean, that was just some definition, but using what we know now, let's actually evaluate some of these problems. So log base 7 of 49, what does that equal to? Well, again, this is asking the question, 7 to what power is 49? So 7 to some power of x is 49. Well, I mean, hopefully we know at this point that would mean that x is a value of 2. Because 7 squared is 49. So log base 7 of 49 is equal to 2. Nothing crazy so far. Let's continue on. Log base 3 of 27, what is that equal to? That's equal to some value x. So remember, x is our exponent in a way. Like, so, 3 to the x power is 27. Well, hopefully we know that 3 to the third power is 27. So x must be equal to 3. So log of base 3 of 27 is 3. So this is just our common knowledge of exponents. Nothing crazy. Alright, now we got a log of 100. What is that equal to? Okay, well, remember, this does mean a log base 10 of 100 equals, well, what that is saying is 10 to what power equals 100. And that value is 2. So the log of 10 is, no, the log of 100, sorry, is 2. X equals 2. Because, again, 10 squared is 100. Now, log base 12 of 1. So 12 to what power is equal to 1? Well, then x has to be 0. Because anything raised to the 0th power is 1. The examples we're doing right now aren't so crazy. 2 to what power is 64? You can go through them with trial and error if you really are having trouble, or you could, if I didn't know what this was off the top of my head. Well, I do know 64 is 8 times 8, which is 8 is 4 times 2. So 4 times 2. 4 is 2 squared. So you got, count up all the exponents. These are to the first power. 2 and 1 is 3. 2 and 1 is another 3. So that's really 2 to the 6th power is equal to 64. So my x is 6. That was an overly complicated way of doing it, but, you could have... What am I doing? No, 6, yeah. Yeah, you could have just, literally went in your calculator and tried, all right, 2 to the 3rd power is whatever, 2 to the 4th power is whatever, and gone all the way up to 64. Just something like this. 3 to what power is 243? Well, 2 to the second is 9, 2 to the third is 27, 2 to the fourth is, I don't know. The answer is 5. So 3 to the fifth power is 243. So x is equal to 5. And then, you might run into some sort of fraction problems. Do not be dissuaded. So we have 9 to the x power is equal to 1 over 81. Well, 81 in particular is 9 squared. So, 9 to what power is 1 over 9 squared? But we know 1 over 9 squared is really 9 to the negative 2. Because as negative exponents, you put them on the opposite side of the fraction. So x is equal to negative 2. Negative 2. And then, alright, 64 to what power is 4? Well, I don't know. I know that 4 to the third power is 64, or if I took the cube root of 64, then I would get if I took the cube root on both sides, I would get my answer. So the cube root is 1 over 3. So just, again, if all this is too tricky, you can always just use a calculator. I don't know. I hate to say that, but whatever. Anyway, that is it for those problems. Next video, we'll cover another topic, or another, not topic, but another application of this topic.